Okay, so welcome everyone. We are officially live for one more of our seminar series, which is part of a collaboration effort between Open Neuroscience, which is an online repository, community-led, where we're hosting information about open source, open science projects for neurosciences, and a worldwide series, which is again like another community-led effort around the world with many, many different seminars that started during the pandemic. And now we have many, many different topics and subjects. And one of them is this one, which is where we give space to developers and people who are working on open source and open science projects to talk about their projects in neurosciences. And today we have the pleasure of having Kendra Udik. I'm sorry, I'm hoping I'm pronouncing this correctly. Yeah, probably not. Sorry about that. But Kendra recently defended her PhD in neuroscience, specializing in meta-research to enhance research practices and reproducibility in the field. Her work uses text mining to explore scientific literature, aiming to understand and improve how research is conducted and disseminated. Kendra also co-founded the Open Science Office Hours, which is a community-driven initiative at the Neuro in Canada and McGill that supports researchers in adopting open science practices. She's also very passionate about teaching and is a certified instructor at the Carpentries. Kendra, it's a pleasure having you here with us. Kendra mentioned that if you have any questions, you should definitely interrupt us and either write on the chat or raise your hands so that we can mediate. But yeah, Kendra, the floor is yours. Take it away, please. Thank you.
Thank you so much, and thanks for the invitation. I'll just share my screen now. There we go. Can you see my screen?
Yes, we can.
Okay, perfect. So my presentation today is called Towards Doing Meta-Research in Neuroimaging. And we'll go through definitions of what that means in a moment. First of all, research, as we all know, has profound consequences for society, and it should be held to a high standard, and so I argue that we need meta-research, or research on research. And it's rapidly changing, so I argue that meta-research needs to be able to keep up with changes in the literature. So meta-research is the study of research itself, its methods, reporting, reproducibility, evaluation, and incentives. And we propose living meta-research as meta-research that is reproducible and updatable. So the objectives of this project, which is the culmination of my PhD essentially, is first to introduce the concept of living meta-research, then to describe tools for living meta-research that are accessible, scalable, and reliable, and finally to provide an example of living meta-research in the paper that describes and scrutinizes the field of neuroimaging meta-analyses. And overall, our objective is to move towards living meta-research in neuroimaging, thus improving the field and the knowledge that comes from it. So in the first paper, I'll introduce the concept of living meta-research. So first, I'm just going to go over a few examples of past neuroimaging meta-research so that everyone can get an idea of what meta-research is for. So, for example, in 2013, Button and colleagues showed that low statistical power in the neurosciences is leading to inflated effect sizes in the literature. In 2016, Eklund and colleagues showed that some cluster inference methods, which are methods of thresholding brain images, can lead to more than 90% false positive rates, which is quite scary to me. And then 2020, along a different line, Dworkin and colleagues showed that women scholars are systematically undercited in neuroscience. So these are all examples of meta-research in neuroscience or neuroimaging. And the point is to ask the question, are these problems still relevant? They were done maybe a decade or a few years ago, but we haven't had an update, so we don't know if just publishing the paper was effective enough at solving the problem. So So this is why we propose living meta research, or research that's reproducible and updatable. Why is now a good time? Well, some technological advances recently have given us the opportunity to improve automation, which will make it easier to repeat meta research in the future. So, for example, if we use a large language model to extract information from texts, so for example, whether or not those cluster inference methods were being used, then if we automate that process, then in a few years we could just run the code again and see if things have changed. And how will we get there? We argue that we need standards and tools to help us do meta research in a more reproducible way. And there's a few possible standards that we could adapt for this. One is the methodological expectations of Cochrane intervention reviews. So you'll notice that a few of these possible standards are meant for meta-analyses or reviews, which are arguably a type of meta-research, but they've been around longer, so we've had more work on building standards for them. Another option, which you might be more familiar with, is the preferred reporting items for systematic reviews and meta-analyses, which goes over what to report in the review, and many of the points are relatable to meta-research. So, for example, you have to show the search string you used in order to find papers that you include in your evaluation. In the case of a meta-analysis, that's an evaluation of the results, but in the case of other meta-research, it might be an analysis of the methods or an analysis of what, how they're communicating, for example. And finally, Elliott and colleagues in 2017 published some guidelines for living systematic reviews, and they go over how living reviews can work in practice. So this idea of living research is not new, it's just new to apply it generally to meta-research. Very exciting. Soon Prisma is going to have an official adaptation for living systematic reviews. So here's some scenarios for how we could update meta-research. Now this was specifically meant for living reviews, but it could apply to meta-research in general. So first, after a paper is published, we survey the literature regularly and ask if there's new evidence. So for example, this could be rerunning some code and determining whether the results have changed significantly. Then you assess that new evidence and then ask whether that actually has a consequential change, or does it change the message of the paper. And if it does, you should update the analysis and conclusions and then disseminate that information. And this is shown as a loop because this process repeats, say until results have been stable for a good amount of time, or the question is no longer relevant. And we'll come to an example of a question that we could sort of retire in a bit. So some technologies that can be used to increase the reproducibility and automation of meta-research include using APIs for collecting papers instead of manually downloading PDFs. For extracting information, you could use heuristics, which is just like a set of rules for extracting information. For example, defining how a text is, how people usually talk about something like the number of participants, and then using that to extract the number of participants. Or you could use statistical models that have learned to extract that information. Then for the analysis, we could use custom code in R or Python or some other language in order to make it more reproducible instead of using a graphical user interface. So for a small example, we looked at how open large data sets are used in the field. And we used this list of data sets cited in the paper by Andrew Laird about functional connectivity. And we used a simple heuristic, which is just, again, just a set of rules for extracting information. And the simple heuristic was simply to look for the name of the data set in the methods section of the papers. And this gave us 86% accuracy, which is pretty good considering it's a really simple rule. And we can see that there's a stark outlier here. The Human Connectome project is being used a lot more than other data sets. And this raises the question of when do we stop using a data set? Like when have we discovered all we can from the data set? On the other hand, the Human Connectome project isn't simply one data set. And so we might be getting multiple data sets in this one. So for example, the adolescent version or the adult version counted among the same account here. So take it with a grain of salt, but basically the Human Connectome project is being used a lot, and we should think about when to stop using it. So in summary, for this paper, we propose living meta-research with definition, standards, technologies, and an example. And some limitations in future are that we should actually be creating new standards and practices in a highly collaborative way. If anyone is familiar with the PRISM collaboration, it's a diverse collaboration with scholars and different stakeholders, publishers, whatnot, who work together in order to create standards for meta-analyses and reviews. And I think that probably for meta-research, we should be doing the same thing. And also we focus on observational research where people collect a set of papers and then extract information from it and describe that information. And there are other types of research which don't fall so neatly into this.
Andrew?
Yeah.
Sorry to interrupt you. There seems to be a little bit of a noise in the background, and it's making it a little bit harder to understand you. I don't know if it's the microphone, because you're the only one who's unmuted, and so maybe, sorry.
That's okay.
It's a little bit like, yeah, it sounds a little bit metal. Yeah, maybe that helps, I guess.
Is this helping?
This is really helpful. Great.
Sorry about that. Yeah, there's some kind of air circulation on. I can't control it, so sorry about that.
No worries. That's much better. It's much clearer. Thank you.
Maybe this is a good time to stop and ask if anyone has any questions about this first paper, which actually isn't a paper yet. It's a paper we're working on still, so if you look for it, you won't find it.
Cool. So I guess it's not a preprint yet?
No, not yet, no.
Okay. Yeah, so Daniel has a question. Daniel, do you want to unmute yourself? Yeah, and ask. Thank you.
Yes, hello. Thank you, Andrea.
Hi.
Thank you, Kendra. So I just would like to see if I understand correctly like the approach in Diapo 10 and 11. You show us like the way an initial meta research can be like updated, and then you propose with APIs that drag articles from somewhere to make the update. Yeah. How feasible is, like in reality, that in terms of the high amount of articles you can, let's call it mine? I mean, I suppose you, like, one can track for specific keywords or etc., like to narrow down the topic, but at the same time I have the feeling like it will be still overwhelming, like if you do the API stuff, I don't know, but weekly, monthly, it could perhaps need a lot of human work to really like kind of select the articles that could update the specific meta research. So in your experience, is that like really the automation, it's like really feasible, or it still needs a huge human input?
It depends a bit on the question. Depends whether there's any process of including and excluding articles. Like in manual meta-analysis, for example, people go through each article and decide whether to include it. But in a lot of large-scale meta-research, people simply have specific search terms they use or specific journals they look through automatically using an API. And the idea is that the quantity will sort of smooth over the noise of some papers being included that maybe shouldn't be. But it's always a trade-off. And definitely in this update scenario, there will have to be human participation in deciding things like whether the change is consequential. Some other things can be updated. This example we gave, we chose a really simple example in order to show something that could be automated fairly easily, and the code could be run again automatically. Regularly, we'd have to revalidate to make sure that we're still maintaining the same level of accuracy, but depending on the question, you can automate more or less, basically. And it's definitely an open problem of like who will be doing this. I suspect that it would be good to involve some academic librarians in this discussion, since they're actually often involved in the literature searching part of meta-analyses already. But yeah, sorry, it's not a one-size-fits-all answer. It depends on the question, really. And you'll see as I go through the third paper, which is an example like of a whole paper, living meta research, some of the analyses, some of the information we had to extract manually. So then in the future, we'd have to extract the information manually again, unless we build a method to automate that. Does that answer your question? Sorry, I feel like I'm rambling a little.
Definitely, yeah. Thank you, Kendra.
Okay, you're welcome. So now we move on to the second paper, which talks about some tools that we've built for doing living meta research. And this is already published as a peer-reviewed preprint in eLife. So as background to this, 2 papers are indexed on PubMed per minute. That was in 2016, so probably there's even more. And we have a need for meta research in order to make sense of the growing literature. However, meta research is challenging, and it needs software engineering in order to be done in an efficient and reproducible way. So we proposed this workflow and ecosystem of tools in order to do reproducible and updatable meta research, and I'll go through each step now. So first, on the PubMed Central website, one can build a search string for a specific set of articles you want. So for example, here I'm searching for papers that have music in the title and fMRI or functional magnetic resonance imaging in the abstract. The idea is to get fMRI papers that look at music. And then our tool PubGet takes this information and builds a query for the API and retrieves the journal articles as nested XML, which is quite complicated, and not all researchers are equipped to deal with information in this form. It's very machine readable, but not human readable. So we output most of this information as tabular data or as, well, and or as text ready for manual annotation. So the next step is to extract information from those texts. And for that, we have LabelBuddy to do that manually, and we have PubExtract to do that automatically. And the idea is that you annotate a set of texts and then either directly analyze those annotations or use it as ground truth to build an automatic method for extracting that information. So for example, we built an automatic method of extracting how many participants and how many, the male-female ratio, and the diagnosis, for example, of clinical neuroimaging papers. And then finally, we can actually analyze the data or visualize the data, and you'll see this figure in a bigger form in a few slides. Or in the next slide, actually. So the example we have here is replicating and extending this paper by Poldrack et al. From 2017, where they showed that the median sample size in neuroscience is increasing. They used 2 different data sets to show this, and we both replicated their initial findings. You see that in the green and blue, similar to the green and blue here. And we also extended it using our heuristic that I mentioned, as well as using GPT-3. And you can see that the median is still increasing over time, but given some recent research on how many participants we actually need in order to make good inferences about, say, brain and behavior, we could say that we're still not having an adequate effect size, or sample size, sorry. And you can also see that PubExtract are a simple set of rules, and GPT, we're giving a fairly similar answer, which is very interesting and promising.
Sorry, Kendra, what should be, I mean, is there any indication of what that sample size should be?
Well, it depends on the type of problem, but there was this recent paper, I'm trying to remember the author, the first author, where they showed that for brain-wide association studies, you need in the order of like thousands of participants. Obviously, not everyone's doing a brain-wide association study, but it was kind of a wake-up call for the field in thinking we need maybe an order of magnitude more participants than we've been currently using. It depends on the question being asked, of course, so maybe it wasn't wise of me to make a blanket statement like that, but I think in general people agree we're underpowered. Sorry?
Sorry, I'm sorry I interrupted you. That was terrible.
Oh, great.
That is, I mean, but that's very informative, right? In the sense of that the critical thinking about the studies themselves would allow us to do, yeah, I guess the whole point that you're making, right? We need this to make better research. Sorry, I'll shut up.
No, that's fine. Thanks for the question. So in summary, we provide tools that are accessible, scalable, and reliable, and I can give a little demo at the end if we have time. And one limitation is that we only access open access articles from PubMed Central, and this is for a variety of reasons that make the tool easier to use for a variety of people and make the whole pipeline a lot simpler. But it means if you need if you want to get all the relevant articles, then this tool won't be able to do that for you. On the other hand, if you only need a representative sample of articles in order to make some kind of inference, like the median number of participants over time, then this tool should be good enough. And in future work, we wanted to do a full project using our ecosystem, and that brings me to the next paper, which is basically a demonstration of our tools on the topic of neuroimaging meta-analyses. And I'll just stop here quickly if there's any more questions about the tools paper.
I have another quick one while people gather their thoughts. You showed that on the search, you search on title and abstract and authors, right? I think. And this was always something that I was interested in. Are there any search, like PubMed, as far as I remember, only searches on these fields? It doesn't, like, for instance, if I have a specific term, it doesn't search on the body of text, right? Or does it?
I'm not sure for PubMed Central, because for PubMed Central, all the papers are open access, so theoretically they could, even if you don't have access to it, because everybody would have access to it. But yeah, my understanding is you can't ask it to look for a mention of a specific word or phrase in the body of the text. You can only do that for the title and the abstract.
Okay, and so my question is there any specific reason for that? Because you mentioned, now we can do these things because of technological development. Is this technology didn't catch up yet on these repositories?
Yeah, it could be. It could be that maybe it's too slow to be able to search through the whole text. I suspect it's probably one of those things that we're able to do now, but the process of getting it implemented and ready for use for the public probably is a lot slower than the advancing of technology. That's my guess. But
Okay, thank you.
welcome. But with our tool, you get access to the full text. So if you want, you can gather a wider range of papers and then use code to select text that specifically mentions something that you want. We do that, for example, in tracking use of software over time. So if you search for neuroimaging papers that use SPM, they probably won't mention they use SPM in the abstract. They might, but not all of them will. And so you need the full text and to be able to search the full text for something like that.
Okay, thank you.
You're welcome. So that brings me to the third paper, and the rationale for this one is that meta-analyses are needed to summarize the expanding literature, and they're considered the highest form of evidence, and so we argue that they should be monitored. So the objective is to describe and scrutinize the field of neuroimaging meta-analyses, focusing on each step and pointing out successes, areas for improvement, and future directions. So first of all, as a success, we see that 65% of meta-analyses have a PRISMA chart, which is a chart that shows how papers were searched for and included and excluded in the meta-analysis. And this is essential for making a meta-analysis reproducible and also just to improve trust in the process so other researchers can see that it was done well. So it increases transparency and reproducibility. And we also see, even more promising, that this number is increasing over time, such that in recent years it's around 100%. So this is an example, this is the example I mentioned earlier of an analysis that we might not need to repeat very many times. If we see that we're at near 100% in the next few years, then maybe we can stop looking at this and just conclude that we're having good adherence to these guidelines. An area for improvement is that overall, like in neuroimaging studies in general, we have low median power in meta-analyses. So Eickhoff et al. In 2016 suggested that we need at least 17 studies in order to have reliable effects in a meta-analysis. And Eickhoff and colleagues later suggested that you actually need 30 studies in order to be robust against publication bias, which is particularly relevant for meta-analyses because it means that the studies that have null results are not being published and so cannot be included in the meta-analysis. So your results will be biased. So essentially we see here that the median number of studies included is increasing over time, but it's not going above 30 yet, which is a little bit worrisome. And this is a really hard problem because you can't, if you don't have enough participants, you can go and find more participants. But if you don't have enough studies for a meta-analysis, if there are no more studies, you can't just go out and get more studies. So this doesn't have a simple answer. Another area for improvement is that only 22% threshold the number of participants included in studies. So this relates to power again. And here you can see for those that do have a threshold, what the threshold is. So 7 papers said the studies need to have at least 5 participants in them in order to be included in my meta-analysis. And 6 studies said that they need to have 10 participants included. And this is worrisome because probably these days you wouldn't really get a study published easily if you had only 5 or 10 participants, unless, say, it was a deep phenotyping study where you're gathering a lot of information from very few participants. But for the most part, these aren't deep phenotyping studies being included, and essentially we're adding a lot of noise to our meta-analyses if we're including such studies. Another area for improvement is that very few meta-analyses use the gold standard method, which is image-based meta-analysis. And this is where you use the entire image result instead of just the reported coordinates of results. And you can see all these other types of models or algorithms use coordinates, and just this one uses the images, and it's used very seldom. This is simply because it's harder to find the data, and there aren't any, well, until recently, there hasn't been a software that can be used to simply do an image-based meta-analysis. Finally, for areas for improvement, there may be some location bias in which papers are included in meta-analysis. So the way we sort of operationalize this is the correlation between the research and development expenditure of a country and the percent of papers included in a meta-analysis. So for this, we automatically extracted which papers were included in meta-analyses and looked at the percent of total papers from that country that are included in a meta-analysis. So you see, for example, on this end, this country, Sweden, has a high RDE, and it has relatively high percent of papers included in meta-analyses. Whereas on this end, for Iran, they have lower RDE and also fewer papers included in meta-analyses. And this should be taken with a grain of salt because it is not a very strong correlation. And if we had used the p-value threshold that some people have suggested is better, of p is 0.01 or less, then this wouldn't have been significant. So take it with a grain of salt. So in this study, we pointed out successes and areas for improvement and future directions, and it serves as an example of how to use our tools. However, like I mentioned before, many steps were done manually. So for extracting things like which algorithm was used, we did that manually. And so if we were to repeat this in the future, in order for it to be a living meta-research paper, then we would have to do more manual work, or we would have to build an automated way of extracting this information. And future directions would be to look at how well this generalizes to other fields, like maybe in genomics, like are their meta-analyses also increasingly following the PRISMA directions, or do they also have problems with power, and so on. So in general, again, I introduced the concept of living meta-research, described some tools, and provided an example. And overall, we hope that being able to monitor problems in the field with living meta-research will improve the knowledge that comes from it. So I just returned to this slide where I gave some examples of past neuroimaging meta-research. And the question I raised is, are these problems still relevant? And the point of this presentation is that if we turn these papers into living meta-research papers, then we can regularly check, for example, whether people are still using these cluster inference methods that lead to high false positive rates. Some limitations are the overview. The final paper was not a systematic overview, and it wasn't pre-registered. It was exploratory. And so the conclusions are a little bit less solid than if it had been systematic and pre-registered. Again, PubGet only access is open access full text from PMC, which is fine if you only need a representative sample of text, but if you need the full sample, then this tool won't work. And again, there are many manual steps in the examples, and I couldn't describe methods in detail because of space limitations. But if you're curious about any of the methods, I can go into that. In the future, it would be really interesting to explore a continuous integration framework for meta-research. So many of you will know that when you're creating software, you create tests to make sure it's working, and you can use continuous integration to continually test the software to see if it's still working when you make changes. So the idea for meta research would be when we have new papers, we rerun the code to automatically extract information and analyze it, and then have a measure of whether things have significantly changed. And this could be semi-automated, basically, to make it more efficient. Also, I think the next important step is to reproduce and repeat past meta research, because people are aware of this meta research and already know that these problems are problems, and so they would probably be interested in an update. Again, I think we should explore the role of academic libraries in living meta research, and we also want to continue with our collaborations. For example, NeuroSynth Compose uses one of our tools, PubGet, as its backend for retrieving papers. So in conclusion, we use theory, tools, and demonstrations to help the field move towards living meta research, and this should improve efficiency of practice and certainty of results. And that's it. I'd just like to acknowledge Jerome Dacus, who was a postdoc in my lab who did a lot of the software engineering for these projects, and also my supervisor, JB Pauline.
Thank you very much. So if people have questions, they can always write on the chat or raise their hands virtually. Yeah, Daniel?
Yeah, and if there aren't a lot of questions, and if people want, I can give a short demo of the tools as well.
I think Daniel has a question.
Well, thank you, Kendra. Yes, I would like a short demo of the tools. That would be nice. I have a question. So if we look at the end, the strategy as it is, like say updatable and living meta research, that will definitely implicate some, let's call it, alternative platform for publishing and keep it in life. Will be like some kind of, I don't know, NeuroLibre or something like that, no? Like not the traditional PDF, static PDF online that you need to go to months of things and arrangements to do little changes, no? So how it will be? So it will be like a kind of main publication in a journal and then some updatable stuff in some other platform, or we can simply, as I will argue, go to forget about journals and do living stuff as yours in different platforms?
Yeah, it's a really good question, and I think we're a bit lucky that people are already talking about living systematic reviews and meta-analyses, because hopefully they'll figure it out before we need to. But yeah, I think in journals we already have the ability to like make corrections to papers, or people to add like a note to papers, and I think that probably the best way is to not rewrite the paper every time, but to add a little summary at the end of what has changed in the past few years. One idea I had was that, I'm assuming a certain level of tech competence here, but if each paper had like a page on a website like Wikipedia, it could be consistently updated. And I think that would be ideal. But
yeah,
we have to
control, no? Like
version control for papers. Yeah, and hopefully you'd be able to look at past versions of the paper and see how things have changed. Yeah, it's a really interesting problem.
Cool. Thank you, Kendra.
So Marco's right. This would be so good. Yeah. Sorry. Yeah. So just one question, I think, before, if the demo, Kendra, or if people have more questions, of course they can ask, but I have one as well. Is there anybody talking to fund? Because what I'm thinking about is, as communities, we always seem to know what we should be doing, but then individually, it's really hard to do because of the incentives, right?
Yeah.
So is there anybody trying to work with, funders and journals to say, look, the new guideline is that, if you're going to get funding from us, this is what you need to do, in a way to try to align these two things, so that it's easier for people to adopt this?
Yeah, that would definitely be a good next step. I think probably we'd have to establish that it's useful first, that it's needed, and maybe showing like how we can track a few problems that were pointed out in the past and see how things have changed. I think that would be a good motivation for it. Again, I think because the systematic review community is already looking at this problem, I think it will be easier once they have established that meta-analyses and reviews should be living, which I think is happening slowly, but it's happening, and I think it'll be easier to ride on the tail of that. Yeah.
Okay, sounds good.
Sorry if that was a we'll wait and see answer, but
No,
sometimes you.
Sorry.
Yeah.
Just there is no good answer for it. I just imagine that,
Yeah.
like, maybe someday when I ask this, people will say, "Oh yeah, we're working with X and Y Z funders, and we're changing, But this is a whole,
Yeah.
like, it's a very different and yeah, never mind.
Yeah. I think once the idea is more out there, like once we publish the first paper on just introducing the concept, hopefully it'll start a conversation. And again, I think creating these standards and figuring this out should be collaborative. So I really hope we can, maybe at OHBM or something, get together a group of people who do meta research and talk about how to go forward with this idea. There's a question in the chat.
Yeah. So Marcus is asking if it continues updating vulnerable to paper mill manipulations.
Well, I don't know. Because I don't see you getting another citation every time you update the paper, or another indexed paper for your list of papers. If anything, I feel like it would. I mean, it's work that doesn't have a very, selfish reward for a researcher. Like, it's good for science, but is extra work that doesn't give you a specific benefit. What do you think? Does that ring true, or?
Yeah. I mean, knowing that this could be manipulated, then you could try to also like foresee, as you said, right? Like not every update gets a new citation, right? Maybe it's more of a versioning kind of thing, right?
Yeah, that's
I don't know
true.
what Marcus.
Yeah, I mean, there's the carrot and the stick. If we can get funders to require that, or journals to require that meta research and meta analyses be updated, then that would hopefully also be effective.
Cool. Are there any other questions, or are there any other? Yeah, I guess if Kendra would like to do a small demo, I think this would be interesting, right? Everybody who's around. Yeah. Well, thank you.
So I'll start by just showing you the website for our set of tools. It's litmining.github.io. If you search for GitHub lit mining, you should find it. And it briefly describes the tools and gives some examples of code you can run in order to use it, how to install everything. But I'll just go through a quick example here. So here I've got VS Code open as well as my terminal. And here I have some bash code that I can run in the terminal that will run pubget. So you can just type it in the terminal, like I could do pubget run and then type everything, but I find it easier to remember what I did and to reproduce things if I have a actual file with recording what commands I used. So you can do pubget run, and then you can do a query like, say, fMRI and music, or you can go to PubMed Central, do a query, and download the list of PubMed Central IDs like I've done here, and there's just 2. So for this query I just ran, I'm just curious about how large language models are being used in fMRI research. So I just search for papers that have large language models in the abstract and fMRI in the abstract, and only got 2 results, which is handy for doing a short demo. You probably want more than that. You definitely want more than that to make any kind of inferences. And then I say that I want Label Buddy. I want the texts prepared to be manually annotated in Label Buddy. I want the texts vectorized so I can have TF-IDF, or term frequency, inverse document frequency values for every term in the papers. And that can be used for things like a topic analysis. And Nightmare is a Python-based program for doing meta-analyses on neuroimaging studies. And if your papers that are found by PubGet have coordinates in them, PubGet will extract those coordinates and prepare them in a way that can be easily used to do a meta-analysis in Nightmare. This is another plugin that allows us to extract the author locations. And then here I just want to give the name of the data set a name that I can understand. You'll see in a second that by default it's named as a hash of the input. So in this case, a hash of the input PubMed Central IDs. And if I'm not making sense for any of these things, feel free to stop me. I'm not sure what the background of everyone here is. So if I'm in the folder where this file exists, and I can run it with make test, just a period to indicate the current folder, and then the name of the file, and press enter. And then here it says it's getting 2 IDs. Right now it's on to the step of extracting author locations, and it's done. And so I can see this data set here. This is just a symlink to the original file, which again is a hash of the PubMed Central ID list, so that if you run it again with the same query, say it didn't get through all the way, if you have like thousands of papers you're downloading and something happens and it stops, then next time it can find the folder that is for the same query or the same list of PubMed Central IDs, and keep running the code to get the rest of the data. So this is just one way that PubGet is really efficient. But if I look in this folder, I can see, for example, all of the articles ready to be imported in Label Buddy, and it's just a JSON-L file with things like fields like the text. So it starts with the author names, and then it goes into the abstract, and this is really hard to read because it's not formatted very nicely in just the JSON-L file. But I can open it. I can open Label Buddy by just typing in, I have Label Buddy installed. I just type in Label Buddy and the name of the database I want to create. So you don't need to understand this all, but Label Buddy basically has a SQLite, SQLite database behind it of all the papers, and adds the information from the annotations to that. And that's why we create a database. Basically, this is initializing a SQLite database. And then that opens Label Buddy. And there's 3 tabs here. There's the Annotate tab, Labels and Documents tab and Import Export. There's nothing in it yet, so I'll just go and import the data. So I just find the data. It was called test PMC dataset. And I find the documents file in the Label Buddy folder. And here it says it added 2 documents and no annotations. So in the Documents tab, I can see the 2 document names. And here I can see the full text of the article. So I can create a name like which LLM was used, which large language model was used, for example. And I can see just by glancing through it, it looks like they use ChatGPT. So I can give that a label and then go to the next paper. Even by just looking at the abstracts, I can get a lot of this information. So here, and I did look at these papers already, so I wouldn't have to take too long to give this demo. But so then I can label all the papers and export the annotations, and we have some more tools for creating a database of all the annotations and interacting with it in Python in a way that's it's just in a pandas data frame, so it's pretty easy to deal with if you know how to deal with pandas. Yeah, are there any more questions about this demo or anything else you'd like me to show? Oh, somebody has their hand up.
Yes, I do have a question. It's clear you explained that it has access to the free documents available in PubMed, but what about if I have access to another data set? I have the PDFs match with the PubMed ID, for example, that I have that are not available in PubMed, but I have them from another source, and I have a list of PubMed IDs of those PDF.
That you have access to.
Of the code and...
Well, if you have the text of other papers, you could format them in a similar way to the input of Label Buddy and just import them. You just have to create a JSON lines file with a few different fields. We don't. So PDFs are actually notoriously difficult to work with when you're doing literature mining. There are some tools that convert PDFs to, like, that just extract the text from PDFs. I'm not aware of any at the moment, but I can ask if you're curious. I know someone in my lab is using one. And the other thing I wanted to mention is that we also have code that allows us to get abstracts and like the open information from closed access papers from PubMed. So for something like what I was just showing, it might be good enough to just have the abstracts, but we're still working on integrating that code into the main tool. So right now we only talk about it accessing the open access files. So definitely in the future, it would be interesting to try to somehow integrate institutional access, but that would be really complicated and kind of out of the scope of what we can do right now.
Okay.
Yeah.
Right, thank you.
Welcome.
I have a question. So you annotated 2 large language models, right? Like you created the field that you wanted to annotate and then found ChatGPT and another one, right?
Yeah.
So this means that, like right now you're doing this manually, but let's say you come tomorrow to do another set of reviews, right? Like another set of investigations using Buddy. Are you guys thinking about that you then could already have these keywords as part of the database to automatically find them on the next papers so that you don't have to find them again? Or
yeah, definitely. You want to have, we usually aim for around 100 validation papers labeled when we create an automated method that doesn't involve any learning. Like if we're just making a heuristic, like search for this word in these papers, then we still want to validate that it's working. But yeah, for some things like this, it might be pretty simple. The thing where it would get complicated is like here by reading the sentence, intriguingly chat GPT, blah, 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 blah. It's not super clear just from this sentence that they actually use chat GPT. It just mentions chat GPT, so that might be something that would need more human attention. But definitely if you're just searching for mentions of names of large language models, that could work well. The problem comes in, like, ChatGPT is a pretty unique name, but something like BERT, I don't know if there would be other, say, medical conditions that have this as an acronym. I came across that when I was doing the data set piece, where I was searching for data set names in papers. Sorry, PowerPoint is frozen, so I can't go to the slide. But when I searched for things like HCP for Human Connectome Project, I was getting false positives of finding papers that mention a disease that also has the acronym HCP. So it really depends on how well the acronym was chosen and how unique it is.
Okay.
Yeah. So one of the interesting and difficult things about literature mining is every piece of information you look for is different, might need different methods. But that's also why things like large language models are exciting, because they're sort of like generally good at finding information. Yeah.
Okay, that's pretty cool. That's pretty good. So, yeah. Okay, so always the details, right? Because in principle, you could
Yeah.
there are all the details. Okay, cool. Yeah. Any other questions from the audience or any other points you'd like to raise, Kendra?
Just that I wish more people were doing literature mining, because I think it's the subject experts that have the interesting questions. And I happen to be a bit of an expert on meta-analyses, so that's why I looked at meta-analyses. But yeah, if the goal is that subject experts can just do like a meta research paper on a question they're interested in without too much software experience. So.
Okay, cool. Yeah, so this is, I guess, the take-home message for everybody.
Yeah, yeah.
Do read Kendra's papers to see how they're making it easy for people to do also this kind of meta research, and tell a friend that might be super interested in doing it, right?
Yeah. I think when I talk to researchers, almost everyone is interested in meta research, because you're basically studying yourself. So.
Cool. Great. I guess there are no more questions. I would like then to say thank you, Kendra, very much. This is pretty cool. I'm really glad that we had you over to give this talk. And we're excited to see when the papers come out and see what you guys find out going further into the studies. Thank you very much, everyone. And yeah, I'll see you next time. Bye-bye.
Thanks for coming. Bye.